Good. Hello. Hey, it works. Okay, you ready to go? Hey, the lights are coming up. Wow, this is cool. I don't promise to be nearly as fun an MC as Rosie or really anyone else, but I'll try to get the job done. Housekeeping. It's time for housekeeping. What housekeeping is there? Breakouts. If you haven't signed up, proposed a breakout topic, the list is still out there. We have one break to go before the breakout sessions, and I will just pull the easel sheet off at the end of the break. So get your breakout topic on that board before 2:30. And then we've also got lightning talks. I'm not sure, I didn't look at the list to see how full the list was. There are 12 slots, so they may already be full. But if there are any slots available, you should sign up for Lightning Talk because they're awesome. Yeah, and I think that's about it. Our first presentation for this section is Dan Scott from Laurentian, right? Laurentian University. Structured Data Now, seeding schema.org in library systems. Dan Scott.
All right, so are we projected? We are not projected. How does one get the projection up? I came up here early.
Yeah, it's open, so.
Oh, you're doing just off of one. He's not using PowerPoint.
No.
Okay, gotcha.
Hit escape. Yeah. You may need to close it entirely.
I might need to.
Excellent. Okay.
Oh.
Don't leave, Riley.
Okay, and then you need to change yours. And then you go ahead and bring your presentation back up as soon as you.
Okay.
Sorry, we thought you were doing PowerPoint. We had it set up for the PowerPoint.
Okay. And back to Mozilla. And back to the URL. Sorry, folks. There we go. So you can follow along at stuff.coffeecode.net/2014/structured-data-now. You can't. Oh, right. Those of you on the live stream can follow along. Oh, it's not going to, okay. So we can't do full screen, I guess? That's fine. Yeah, tried it. Yeah, good enough. There we go. Okay. We're happy. Sorry about that. Thanks for getting things going on the timer, Peter. I'll make use of that. So, two things. We've heard about people who are going to discovery layers because they're finding that general search engines are a better way of accessing the resources for your library. One of my basic premises is that why not just make the general search engines better able to find the resources from your library? And we also, I think, want to make our metadata reusable and accessible by people who are not necessarily skilled in the dark arts of library technologies. So at this point in time, 25 years on with the web, the world's largest search engine internet company, arguably Google, is still getting things wrong in identifying structures of web pages. So at the top, we've got the credits for the picture for Chris Hadfield showing up as the title in Google News. We have changed text size for the story coming from my hometown, Barrie Examiner. They need to learn a little bit about HTML, or Google needs to learn about them. And we've got the mixed reactions to the South Korean free trade deal. Why am I alive? Why are you alive? I'm not complaining or anything. That's pretty dramatic. So we have been really early technology adopters. We've seen the potential of technology to increase access to our resources, for our patrons to reach in and get access to our things. So Telnet and web access to catalogs, obviously, early on. We've decentralized our structure. So we had Z3950 early on, an amazing innovation for a way of sharing our metadata and reducing our labor costs. We had OpenURL and coins and UnAPI, different ways to provide access to resources, to provide structured, different representations of metadata for things like citations, things like Zotero and Mendeley could take advantage of that. But these are almost entirely library-specific technologies. And we still have this guy hanging around, probably long past his prime. Mark, in case you're missing that at the top. Still kind of a big deal in the library world. So, my alternate title for this presentation is I'm a Semantic Web Dropout. And I joined the library world again in, say, 2006 and was pretty excited by a lot of the semantic web stuff. So I wanted to work with Evergreen and bring it onto the full-on semantic web, but I'll be really honest, I got hit over and over again by all of these terms and concepts and a deep set of knowledge that basically just said, or made me say, really? I know there are people in this room who are really smart and who are probably grinding their teeth right now. It's not that hard, Dan. Why can't you just pull it together? But I just decided to work on Evergreen for a few years. But then I was at Google I/O 2011, and the person on the left, Timothy Jordan, was talking about scalable structured markup. He was talking about it for rich snippets, and it was very specific to Google, very specific way of marking up your HTML, so I kind of discarded it, but thought it was an interesting idea. And a few months later, schema.org was introduced. Schema.org was an initiative by the major search engines agreeing on a common vocabulary for describing things. They saw the world of the semantic web maybe sort of the same way that I did, where it was a really academically interesting space, but really difficult for normal people to be able to use and adopt in day-to-day sort of web markup. So they're really interested in the short tail of web results, things like events, what's an upcoming band that's going to be playing in your town, products, because they can make money off of advertising, obviously, but it's something that we look for on a daily basis through things like Amazon. We should be able to do aggregated searches across those. And people, usually more salacious celebrity details than finding out deep research on people, but they made sure that their vocabulary would mark these, or make it easy to mark these things up. And they provided lots of examples so that you could use RDFA Lite or microdata to mark up your HTML. So regular webmasters wouldn't have to be semantic webmasters, just a regular webmaster, just taking the same skills they already have and applying it to what already exists. And this would, of course, give the search engines the ability to do a much better job of disambiguating these things, avoiding those problems that we saw in the Google News stream where they're misidentifying titles or the basic content of the page. So if you're not familiar, it's worthwhile taking a really quick look. I'd encourage you to take a look at this yourself. This is at schema.org/thing. A thing is the type from which every type in schema.org inherits. So you've got just a handful of properties there, things like description, name, URL. And you can see at the bottom there are more specific types, right? So we're going to specialize as we go down, inheriting all the way along. For libraries, we're primarily interested, I think, in creative works, that category. That's the first level of inheritance from thing. And it mixes in properties like about and accessibility properties that were recently added to the schema.org vocabulary. And then further down underneath creative work is book. And book has, as you would expect, book-specific properties, things like ISBN, number of pages as an integer, which caused a lot of fun in a discussion later on. And then there's the focus on examples. So they'll put the original HTML and they'll follow it up with what this would look like with schema.org. They generally use microdata in their markup, but we'll worry about that a little bit later on. It's easy to deal with. So With this happening around July 2011, the first system that I knew of that was publishing any sort of schema.org was Evergreen. I had some patches published to get the title author keyword sort of level of description available. A very generic, very simplistic approach. And OCLC WorldCat, very shortly after that, published a pretty amazing approach using JSON to encode the schema.org vocabulary. And they extended it because they found that schema.org was missing a whole lot of things that we in the library and bibliographic community would be interested in expressing about the works and the resources that we have. So that's all cool, Dan, but what's a problem that we really kind of care about? What I care about is something like this, where if you do a search in Google Books and you get a book result, there's a really handy find in a library link on the left-hand side. But when you click on that link, it takes you to WorldCat. So the problem with that is that if you're not in OCLC, then you're not linked via Google Books. And all the work that we put in as a library community in decentralizing our information, making it available and readily harvestable by other entities, has gone away. We've allowed ourselves to be centralized in this one specific instance. I want to kind of be able to avoid that or provide alternatives to that. Another problem, at I/O 2012, there was a presentation about Google Plus local pages and how great they were that you could get your address information and your telephone number and website address and your opening hours there. And schema.org has a library entity that you can describe. And so, kind of being a bit of a devil's advocate, I asked, wouldn't it be nice if Google Plus had a write API so that we could push the data to it rather than, have yet another spot where we need to maintain all this information, right? It's hard enough keeping it accurate just on our own institutional web pages, let alone a whole bunch of other social media sites. And so you end up with situations like pretty good representation of the State Library of North Carolina here. We've got hours and the website and address information, and pretty good information in Bing Maps. This varies wildly. If you do a comparison of Google Maps to Bing Maps, you'll see differences for many institutions. In this case, it's pretty close, but because they've got the Find on Facebook link, you'll find that Bing is actually pulling this information, it looks like, directly from Facebook, the page that they're maintaining there. Then if you go to OpenStreetMap, Raleigh State Library doesn't even show up on the results. And there's a lot of information on OpenStreetMaps. It's something that should be there. A lot of other libraries are there, but it's not there. It's not present. I'm not doing this to say, like, bad Raleigh State Library. I'm just saying it's a shame that it's not just automatically there. So earlier I had shown Ron Burgundy, the mark of our times. Mark is the Ron Burgundy of our times. So there are linked library systems that have shown leadership for the rest of us, but they're big. They're not like many of our libraries. They're not a national scale. We don't have the ability to run concurrent systems. We don't have the ability to mandate changes to workflow. Or if you do, you've got great power in your workspace, and I need to learn from you how to do that. So my hypothesis is that we can iterate towards linked data. We don't need to completely rewrite our library systems from the ground up, but we can start enriching the data that we publish, and that we can use web standards to do it so that we're closer to normal developers or a broader pool of developers who can both use and work with us to improve our systems. And so that's a pretty simple set of web standards to look at. Persistent URIs, HTML, HTML5, RDFA, using schema.org as sort of a common denominator vocabulary, and sitemaps that tell anybody who's interested in aggregating all this information what URIs they should care about. As it turns out, I think I kind of independently rediscovered all of which the Library Linked Data Incubator group had probably agonized in great detail over, which basically said, use web standards. Libraries should participate in the standardization of the semantic web. Rather than creating our own vocabularies, we should try and map to existing vocabularies. We should use URIs. I wasn't actually aware of this until about less than a week ago, to my embarrassment. Probably because I was in the stage where anything about linked data or the semantic web was just billions of triples and Sparkle and RDF, things that I didn't have any sort of understanding of. So I just wanted to call out that this group has done amazing work. If you go back and read the report, and a lot of the people who are involved are Code4Lib regulars, people that I've seen a number of these people here today. So thank you for that. So Jason Rinaldo, who is also apparently really good at having multi-channel presentations using WebSockets, analyzed the common crawl data. The common crawl is a collection of websites or web pages that's made available for public use in the same way that a search engine creates its own crawl of the web. This is available for the public to do research against. And so he took a set of factors and found that for academic library institutions of the 2012 crawl, there are fewer than 10,000 instances of the relevant schema.org types in the web pages you crawled against. That's really low. So that's potentially a problem in the speed of our adoption. To be fair, July 2011 to 2012, we're fast, but maybe sometimes we're not that fast. So how do we get schema.org represented in web pages? Well, RDF in attributes, RDFA, is the way that I've chosen to go. It actually existed way back, 10 years ago. It was focused, though, on the XML and XHTML use case, and that's probably why many people ignored it, because how many people are developing strict XHTML? Right. So the initial standardization of RDFA had about a dozen attributes that were added to HTML with a lot of complex rules for using it. And in the world of evolution that is standards on the web and otherwise, Microdata came along and said, RDFA is way too freaking complex. Here's about 4 or 5 attributes that you can use instead. Let's just use that. RDFA Lite said, you know what, we can do that too, and adopted the same approach. So they're almost, in many ways, they're almost identical. There are small academic differences. There are differences that make a difference when you're processing it, but I've gone with RDFA Lite. Really, you're looking at adding the vocab property, which says what the default vocabulary you are that you're working with. The type of, which tells you what type is being described at the time. The property attribute, which tells you the properties of the type that's being described. And this is all going by standard HTML scope. So a span within a div, a p tag within a div, within a body is just all being scoped accordingly. There's a few other instances of interesting usage of RDFA Lite, but that's the core that you need to know about. So that page, that very small page that I had there, you can see if you run it against the structured data linter, it'll tell you there's a person type that I found with the name foobar, of course, and there's a scholarly article that I found that has a description, an article body, a citation, a name, and the vocabulary that's in use. So this is not something I've done by myself. The Schema BibX group was really core to this. Schema BibX is short for the W3C.org Schema Bibliographic Extension Community Group, so we just call it Schema BibX. But it was all about bringing together librarians, publishers, anyone with an interest in semantic web or linked data, and looking at what we need to extend schema.org to not have to have the custom extensions that OCLC had rolled out in their initial instance, but to bring it to schema.org proper so that everybody could benefit from it and use it in a consistent way. So again, lots of people that we'd recognize from the Code4Lib community, publishers, Nicholas Lindstrom, who's big in the linked data world, Laura Dawson, who's a publisher, works with the publishers, very associated with ISNI, Karen Coyle coming up again, very impressive people. I can't believe how much work they do. So one of the achievements of the Schema BibX group was to get citations everywhere. For some weird reason, the initial iteration of schema.org had citation only for medical scholarly articles, as though that's the only thing in the world that would possibly benefit from being able to identify the citations that it contains. So now it's living at the creative work level. Thank you to Alf Eaton for that. We also decided to standardize on the good relations vocabulary for exposing library holdings. So rather than creating our own vocabulary for holdings and trying to get search engines and other people to understand what that might be, the likelihood was that search engines would just not care about it at all. We could reuse the same offer vocabulary that is used to expose products to the web. And we'll see what that looks like in a second. So you can see on Evergreen basic search results for holdings, you've got the location, the call number, the barcode, the library that's associated with and its status. Similar sort of thing in Koha. So the mapping looks a little bit weird because we're calling the library a seller. We're calling the call number an SK or a SKU, which is a stock keeping unit, which actually kind of makes sense if you're trying to keep track of things on the shelves. Call number, squint a little bit, it makes sense. A barcode is a serial number. It's a number that's unique to the institution that's employing it and uniquely identifies that instance of the item. So these things actually work pretty well, I think. And here's markup, which you can review at length after to see how we're doing this. This is the same page from Evergreen marked up with holdings. We also, with a great deal of work and a great deal of discussion, have a periodicals proposal that's currently in front of schema.org community. They seem to be, have moved very quickly on creating a draft version of it. Essentially, articles lived without any sort of container that they could live in. So you could have an article that's disembodied, but no way of saying it was published in, say, Scientific American, or is published as part of a newspaper, or is published as, say, part of a book or a Festschrift. So now we have issue, volume, periodical, all have been proposed to be added. And you can now have, which excites me greatly, the ability to create citations that are extremely well structured as a result as well. So I think that opens a lot of possibilities for Zotero and Mendeley and other citation bibliographic management utilities to go perhaps a step forward in standardization. And comics are something that's coming up. And so we've actually stopped work on new extensions. We think we've done most of what we need to do for the short tail of the bibliographic semantic web. And we're now in documenting mode for best practices and trying to provide support. So feel free to join the community, post the mailing list. We'll do our best to provide you with best practices or consistent approaches. So what have we done? With Evergreen, we actually have links from holdings to the library types coming out in 2.6. Koha and ViewFi 2.1 already are publishing bibliographic data and holdings. Blacklight has added schema.org support as well. We've got about 4,000 library systems that are going to be publishing schema.org data by default as they upgrade and adopt this technology. And open source library systems were the reference implementations for our work. I also have to give huge props to OCLC for providing the 194 million open work. Check this out. I was going to take a screenshot, but Wi-Fi. So in the end, I'm just going to point at these resources because my time is done. Feel free to check out these slides, more information there, and I'd look forward to talking to all of you, or many of you, after. Thank you very much. So do you want to kill
You
that?
used up all your time, no questions.
Exactly.
Hey, now's the fun part when I realized that I signed up for being the MC without looking at people's names, which, I'm not so good with Norwegian names, but I'll give it a shot. All right, so I believe up next we've got Next Generation Catalog, RDF as a basis for new services. All right, let me give this a shot. Anne-Lena Westrum, Benjamin Rokseth, Asgeir Rekkavik, and Petter Goksøyr Åsen. How was that? Oh, no, all right, I'll take it. Oh, and can we get tech folks, Mike and Riley, up here just to make sure that the slides, et cetera, are A-okay? Thank you.
Well, first let me just say that he pronounced my name way better than the guys at Starbucks.
Can you say how it really goes?
Well, in Norwegian it's Anne-Lena, and in English it would be something like Anne-Lena. But yesterday I was called Neil in Starbucks. So, well, first of all, thank you very much for having us. It's a great pleasure to be here. I'll try to stutter through this in English. And to keep you awake, I have 19 slides in 5 minutes. I'll give you the backdrop, and then Asgeir is going to give you more of the nitty-gritty details and the code stuff. I've been so lucky as to be the project manager of a beautiful development team at Oslo Public Library. Benjamin and Petter are obviously not here today, but they say hi. And they are so busy that they could not have the time to look up to the camera. They are at home now and coding Koha, actually, and RFID, but that's a whole different story. So, we're from Norway. That's a little bitte lille, as we say in Norwegian. The tiny country up north, across the Atlantic Ocean. It's almost the size of New Mexico. And 4 years ago, we were living on the dark side. That means inside the library, or inside the black box, also called ILS. When you searched our OPAC for the famous Norwegian author Knut Hamsun, the word discovery layer took on a whole new meaning. It was returning 851 hits for the user to discover. Hamsun did not write 851 works, obviously. He wrote 40. For the time being, we are situated in an old building where 70% of our material is in stacks. That means we have to rely on the OPAC for the users to actually find what we have. But in just 3 years' time, we are moving to a whole new building. They've just started digging now. And the vision is to open a digital mediation and experience center, no less. Sounds cool, right? With the dark arts of the black box. But that obviously means that we have to step over from the dark side and walk towards the light. And hopefully find all the pretty flowers outside the Mark catalogue. And as the title of our talk suggests, we have chosen to step away from Mark and work towards REF and the semantic web. Thanks, Dan. In order to provide our users with user-centered services, hopefully. And so far, we have made 2 services. The first is the active shelves, which is a physical touchscreen device where you place the book on the shelf, and the shelf reads the RFID tag. And then it queries the RDF store and external APIs to present information that is relevant to the book, like reviews, more books by the same author, and here you only have one title or one work, not all the editions we have of a work, like you have in the OPAC. And similar books. And if you put another book on the shelf, it starts a new session. And secondly, we have collected book recommendations from around the country into one RDF store. And we connect those recommendations to the catalog records via the ISBN numbers. And because it's connected to the catalog records, we can actually query the database for recommended books on a particular subject by a specific author on less than 300 pages. And that is quite cool, isn't it? To actually be able to use page numbers for something. So it's not just the catalogers typing 300p. But obviously, to achieve the goal of a digital mediation center, we must move from the black box and over to an open system architecture. What you see on the right there is actually the draft system architecture for the new library. Don't try to understand it. But what we have done, we have started the preparations, and now you'll get more into the nitty-gritty details by Asgeir.
Yeah, sound okay? Yep. Okay, so I'm going to show you why we're moving away from the present day situation. We want to develop our own search interface. This is the OPAC that we have today. I've made a search here for the novel Jane Eyre by Charlotte Bronte, and I've narrowed down the search to show only printed books in Norwegian. Get 9, okay, because that's how many different publications we have that match that particular search. And as most patrons are concerned, they've found the book they're looking at, they were looking for at this point, but the system disputes that. So now the system demands that that the patron should choose one of these editions, which are basically identical. This is, the eyeless vendors have added some discovery features to the OPAC, which has made it better than it used to be, but it's still not a good user experience. At this page we show, we get a picture of the book, and we have a description of the book at the bottom, and read a rating. Someone else read this book and thought it was good, but if I go to a different edition, and bear in mind this is the exact same book, the exact same translation of the exact same novel, but all of a sudden all these discovery features are missing because the OPAC doesn't realize they are the same because they have different identifiers. No description, no cover image, no reader rating. And if we go further, there's a feature called More Books from the Same Author, which is also a good feature in theory, but when you click it in this case, you get more editions of the book you already were looking at, which is no good at all. I'd like to think of it as this kind of user experience is basically the kind you would have by going to the library and being assisted by a librarian who's a complete idiot, who doesn't understand that this book is unable to make the simple common sense assumption that this book called Jane Eyre by Charlotte Bronte has something to do with this book called Jane Eyre by Charlotte Bronte, because they have different identifiers. So in order to do something about that, we have to add that common sense to our library data. And there's no room for that in the MARC format, so we have converted our data to RDF. We do that by the use of a toolkit called MARC2RDF. MARC2RDF is an open source toolkit which has been developed at Oslo Public Library. If you look at the bottom right corner, you should see a link to our GitHub account. It will be there for a couple of slides. Account's name is digibib. So you can get the code or read the documentation there. It creates an RDF representation of the library catalog by harvesting MARC records through the OAI PMH protocol and converting them to RDF statements, or rather than expressing MARC records as RDF statements, it seeks to identify the information and the semantics that's contained in the MARC records and expressing those as RDF statements. But it doesn't stop there, because once the bibliographic data has been converted, you can start to do stuff with it. So we use Sparkle update queries to modify the converted data or to add new data that wasn't explicitly contained in the MARC records, but that can be derived from them afterwards. And there's also a module for harvesting information that isn't in the library catalog at all, but that can be obtained from outside sources through APIs and joining them to your resource descriptions. I should let you have a look. So this first page is in Norwegian, but that's all, I think.
You don't see it.
Okay, well, no. What can I do about that?
Riley!
Okay, I think I'll just have to, no.
Exit PowerPoint.
That's all? Okay, let me see.
We need the browser. Browser?
You're going to have to run routing a zip line.
What helps? I'm not seeing the same as you guys, so. So this is what they should see. Okay, but now I can't see it here.
Well, no, you gotta bring it up. I don't know where you were.
Oh, okay, brilliant.
I
Yeah.
didn't know where you were at.
Ah, really? Okay, so do you see it now? Yeah, okay. So you missed the Norwegian page. I think that we'll have to do.
Okay, well, we can't see it on the video.
Pardon?
Can you stop mirroring the display? Can you turn off the mirroring or turn on mirroring so they both the screen and the computer have the same display?
Is that okay now? Perfect. So you can control multiple data sets here and also multiple mapping files for converting the bibliographic catalog data. So I'll just show you, is this big enough? Okay, so I can show you the mapping file for the Oslo Public Library's main catalog. The mapping file is in either YAML or JSON formats. Basically, it just lists the MARC fields that you want to express the contents from and states what you should do with them. So if we take, let's take the simple one first, 245, that's the title and responsibility statements. And the contents of subfield A is the main title of the document. And we state that this should be connected with the resource with the predicate DC title, and that the object should be of the type literal. For the main entry for personal name, that would in most cases mean the author of the book or the creator of the document. That one. it's an entry for a personal name in Mark, but we want it to be an entry for a person, and then we want to say something about that person. So the object should not be literal, but an instance identified by URI, and the mapping file instructs how the URI should be constructed from a base URI, and in this case the identifier for from the authority file for that person, and then that instance can be the subject of new RDF triples that say something about the person based on the contents from other subfields. And then you have also the possibility to add conditional choices of predicates based on, for example, the contents of a subfield, like the related terms in added entries. Depending on what the related term is, you should choose different predicates. You can also choose predicates based on mark indicators. Okay, no, that was wrong. Then there are something called rules, that where you add your Sparkle queries to modify or add stuff to the data. Harvesters, where you obtain information from external APIs and add those to your description. And there's the page where you actually run the conversion from. You can, I'm going to do test conversion on one single item by entering the control number. And that should give me all the statements that we have mapped from the mark record as n triples. So this is only the information that is obtained from the mark record. But if I paste, oh, I don't. No. Sorry. Oh. Sorry about this. Yeah. This should be the exact URI for that resource. If I paste that in the browser, I get an HTML display of all the contents of that book, including those that has been harvested from other sources or that has been produced through Sparkle query update queries. So we see here that this book, which is the Norwegian translation of Jane Eyre, is a manifestation of a work, and if we click that, we get all the other manifestations of the same work. So this is a different one, and we see from further down that this is assumed to be similar to a different work. This is based on the likeness between the metadata, between the manifestations of Jane Eyre, and in this case, Sense and Sensibility, and turn has its own manifestations. Okay, I'm running short of time here, so just having to skip fast forward, I think. Oh, where's my presentation? Okay, yeah. Like this. Okay, so I wanted to say something about how we construct works URIs, but I don't think there's really time for that. It's basically based on identifying works by the same simple common sense observation I mentioned earlier, that if two books are created by the same person and have the same title, they are probably manifestations of the same work. So, what comes after Mark to RDF? This might seem a bit surprising. It's actually RDF to Mark, and this is not because we're turning away from RDF. It's rather that we've fallen so much in love with it that we want to stay there. But we are still going to need Mark records for several purposes, like, for example, circulation purposes and interlibrary loans. We should supply Mark records with the books that go on interlibrary loans for libraries. Okay, that's the time. Stop it, please. that go on interlibrary loans to libraries who don't understand our data. And instead of, but at the same time, there's a limit to how good your RDF data are going to be if you base them on Mark records. So instead of having our catalogers producing Mark records and then using Sparkle and other automated methods to try to guess what the data means, we have our catalogers producing RDF data and then using the automated methods to simplify them to Mark records for those purposes, but we still need them. So I'm going to jump to the last slide and say thank you. And there's an address to the digital development blog at Oslo Public Library at the top there. It has also a few blog posts in English and our GitHub account and our Twitter account, Digibib. So, thank you.
No questions. Okay, so next up we have Kevin Beswick, my esteemed colleague from NC State. He wanted me to say something interesting about him before he came up, and the coolest thing we came up with was that he was Canadian. Also, when he came to work for NC State, he got stopped at the border, and they wouldn't let him in the country for a while, and it was complicated and slightly embarrassing, I guess. So there. So that's Kevin. He's going to be talking about more like this, approaches to recommending related items using subject headings. And yeah, so Kevin. And while Kevin's getting set up, I was realizing we should talk about this whole breakout sessions thing, because my plan where breakout sessions would just magically happen with no intervention is probably not going to work. So this is what's going to happen. When the break starts after Kevin's talk, if you haven't put up your breakout session idea yet, do it immediately, and then I will take the breakout session piece of paper, and during the break I'll assign room locations more or less arbitrarily, and then I'll put it up on the screens, and you can come back here, see where the breakout sessions that interest you are, and then just go forth to those places. Does that sound like it'll work? There is a easel board by the little coffee service in this part of the building. All right, now we have Kevin.
Hello. Are they up there? Good. Can everybody hear me if I stand like here and talk like this? Good? Yeah? Okay. So hi everybody. Hi everybody at home. My name's Kevin Beswick. I work at NCSU Libraries. Today I'm going to talk about approaches to recommending similar items in our library catalog using subject headings. So a brief overview of what we're going to talk about today, the what, why, and the how of these approaches, evaluation. So are these approaches any good? And where do we go from here with the results? So just a little overview of recommendation systems. I'm sure that most people have probably seen these and interacted with these on sites like Facebook or Twitter or something. So if you are not familiar, it's a system that presents a set of related items that would interest a particular user. And there's two ways general ways that this can be done. The first one is called collaborative filtering. So it looks at user behavior. So in the context of a library catalog, this might be looking at full record page view data or circulation data. So, this person checked out these other items with this particular item, so you might also be interested in that. And then the other kind is content-based filtering. So that's looking at properties of content itself. And in the context of library catalog, this could be call numbers or subject headings. So, using properties from the item itself to recommend related items. So why are we interested in this at NC State? Well, first of all, many popular web services already offer this functionality. So the example, Facebook, Netflix, Amazon rely heavily on recommendations to users. Users are coming to expect it. And I think it encourages use and also makes our library catalog easier to use. And also, we opened Hunt Library last year. I think, is this picture blurry? Oh well, blurry Hunt Library picture. So one of the features of the Hunt Library is the book bot. So most of Hunt's collections is stored in this automated storage and retrieval system. So this takes away the ability to physically browse the collection, which some people didn't like very much. So we decided we needed to explore other methods for serendipitous discovery. So what have we done so far in this area at NC State? So we have a virtual browse team that's made up of members from a lot of different library departments. And I've kind of been absorbed into this team, I guess, since starting there a year ago, because I've been working on a lot of projects that kind of relate to this kind of browsing and touchscreen kiosks and stuff like that. So what have they done so far in this area? So they developed the browse shelf feature in the library catalog, so like a call number sorted representation of the shelf, like cover flow style browse. And also the virtual browse kiosk, which you'll see later at the Hunt Library. It's in front of the book bot, and it's like a touchscreen kiosk where you can browse the collection and make requests to the book bot for items. So here's a picture of the browse shelf feature in the catalog. So currently this is the one of the main ways that a user can browse related items from a starting point in the library catalog. So here I'm looking at books related to this Dive into Python 3 book. So a lot of related books show up because we know that this is how libraries organize their items on the shelf. So some advantages of subject heading based recommendation. So when we compare it to call number browse, using this method we can recommend more than just items that are shelved next to each other. So say an item has multiple topics associated with it, it might not be shelved right beside another item that's related to it. So with subject heading based recommendation we can bring this out. And a lot of our ebooks don't have call numbers, but they do have subject heading data when we get it from our vendors. So a lot of ebooks wouldn't never show up in our call number browse, but they would show up when you recommend based on subject headings. And versus the other method of recommendation systems, collaborative filtering, well, it's a little hard to collect reliable circulation data for electronic resources. And since a lot of what we're buying now are electronic resources, they form a big part of the collection, are very important to kind of show up in these browse features and these recommendation features. So we got together, a few of us at NC State, and we came up with 4 different algorithms or approaches to recommending based on subject headings. So the first one's pretty straightforward. We call it most subject headings. So you get a list of subject headings and you just match them based on the entire thing. So fairly straightforward. So the next one we call first subject headings. So this kind of follows the idea that subject headings, in a list of subject headings, the first one is often the most important one in terms of describing an item. And then from there, it just descends in how important they are. I'm not sure if this is still followed religiously or not, but we decided to try this kind of algorithm out to see if it produced better results. So how this one works is we would send in the first one, look for matches on it, and then if there weren't enough results returned, we would go on to the second one and the third one until we had enough results or until they were all exhausted. So the next one we call most subject terms. So this one we divide a subject heading into their subdivisions and call each one a term. and we look for matches on those terms rather than on the entire subject heading itself. And finally, this one's a lot similar to the last one, but each subdivision in a subject heading has a specific category associated with it. So there's format, there's topical term, geographic, general subdivisions, and chronological subdivisions. So in this one, we're able to assign a different weight to each one, depending on, subject or user needs or something like that. So the implementation, it was really quick and simple to implement this. There's really two parts to it. The first one's a Python application that just handles requests and provides a testing interface, and I'll talk about this in a second. And then we use Solr to handle the actual work. So the Python app is using the Flask micro framework. It just handles requests and responses. It accepts a bibliographic ID of an item as input, as well as the algorithm type that we want to use. From there, it just sends a different query to Solr. Depending on the algorithm, it queries a different field depending on what one we're looking at. That uses the Solr Py library. It returns, after we get the response back from Solr, it returns a list of bibliographic IDs of recommendations in JSON format. And we also built an HTML testing and evaluation interface to kind of see how things are, how they work, and how it was ranking things, and I'll show you that in a second. So the other part of it was Solr. So we loaded our subject heading data into Solr using the Solr Mark library. So if you're not familiar with that, it just takes Mark data and you can specify the fields that you want to load into a Solr index. And you can apply transformations to those fields if you want. So it's a really great tool. So we indexed our entire subject headings. We indexed each subject heading term for an item, and we indexed those terms divided into their appropriate subdivisions. So essentially, we're leaning on Solr to do the heavy lifting in terms of returning the most related items. So we just send out queries to Solr and let that decide, how many terms match with terms with other items, and the most rise to the top, depending on the fields that we're looking at. So here is the testing interface. So as you can see at the top is our original item. So we have the title, link to the catalog record, the subject headings in that for that item, and then a list of recommendations, title, and right beside it has the score that Solr assigned to it. And then if you click on each one, it'll expand and show you the subject headings of that item and which ones matched up with it, and a link to the catalog full record. So how well do these algorithms perform? So we did this in two parts. First, we kind of just took an informal look at it to see if there's any ones that were really bad, and so we noticed right away the most headings and the most terms algorithms look to be producing decent recommendations a lot of the times. But the first headings algorithms, we thought that it produced too few results in a lot of cases. So we decided, it's not worth pursuing any further. And the weighted terms algorithm, that was an interesting one because since you can assign a weight to different subdivisions, and this weight might differ based on, a subject or user's interests, and we don't want to ask for user input. And it would take, a little bit of work to kind of come up with generic weighting for all subjects, one that works well for everything, or, if we came up with generic weightings for broader subject areas depending on the query. But so we decided to forego testing on that one for now to see if, the other ones produced any decent results before we focus on, what to weight, how to weight things and stuff like that. So we did a formal test on the algorithms, the most headings and the most terms algorithms. We manually tested 50 titles, and we just wanted to know is either reliable enough and worth implementing. So we handpicked 30 titles representing different subject areas, formats of items, and lengths and amounts of subject headings. When I say lengths of subject headings, I mean the amount of subdivisions. And amounts is just the number of subject headings associated with a particular item. And we took 20 random titles from the library catalog. So the testing was blind, so the people that were evaluating did not know which algorithm they were evaluating. We gave 10 recommendations per item, and we asked them to rank it out of 10 and give 1 point for each relevant work. And we asked for qualitative comments for each set to kind of see if there were any patterns or any, recurring issues or anything like that. So here's some tables or some charts of the distribution of the scores. So the top is the most subject terms results, the bottom is the most headings. So the horizontal axis is the score from 0 to 10, and the vertical is number of occurrences. So as you can see, it scored a 10 most of the time, or more than any other result. But, we want less occurrences down near the bottom, like the 0 to 5 scores, and more up near the 6 to 10. So the most headings algorithm also, return 0 related results a lot more of the time than the most subject terms. So the most terms did a little bit better. But what we noticed about this, the most headings algorithm performed slightly better for shorter and fewer subject headings, but the terms algorithm performs significantly better for longer and higher numbers of subject headings. And in terms of format, we found that government documents and fiction have interesting thematic recommendations to achieve with shelf browse. So government documents are organized according to SUDOC call numbers normally, and they're organized based on government agency and then chronologically. So when you're looking at government documents on shelf browse, you'll see, documents from the same time period and from the same agency, but you won't necessarily get thematic recommendations. And we saw in here that government documents, you can see other government documents that are similar in theme, or you can see other related resources that aren't government documents that have a related theme. And similarly with fiction, it's usually by by author location and time period and author last name. So we were able to kind of get more thematic recommendations, like books that are similar in theme to fiction books that we were looking at. So there were some issues. Here's some observations that we saw. Lots of duplicate titles. These fell into two categories, so older versus newer editions. So we thought that newer edition, it would be useful to recommend somebody a newer edition if they were looking at an older edition of a book, but it wouldn't be useful the other way around, so we'll have to filter for that. And also print versus electronic, so maybe if you're looking at a print book, you might want a recommendation, hey, we have this in electronic format, you can look at it right now rather than the other way around, it might not be as useful. So format, so an example of this is one of the testing items was recordings of nature sounds, and the comment was, if I'm looking for similar items on recordings of nature sounds, I would want other audio recordings recommended to me if there were any of nature sounds before, a book about nature or things like that. So solution to this would be you could incorporate a higher weighting of format on recommended items. And then we have the problem of poorly assigned subject headings responsible for a lot of the poor recommendations. So, just incorrectly assigned subject headings were bringing back some pretty bad results that weren't really related. And also the problem of general versus specific recommendations. So, like if you were looking for a Java programming, but an introduction to Java programming, and your returned results with like a specific Java framework or more advanced topics. That happened quite a few times. So to alleviate this, we could try and automate like review and assignment of subject headings to our collection, but that would be another pretty large project in itself that we would have to explore. So what could this look like? So we haven't implemented this into production yet. It's still kind of a work in progress, but we would probably want an inline cover flow style presentation on a full record page. We kind of did usability testing on our browse shelf interface, and one of the things that we showed them some mock-ups of, alternate presentations of it, and one thing they all almost unanimously liked was seeing like a few suggested titles on the full record page rather than having to click through a link to go see related titles. So this catches the eye of users. Title, something with similar or related in it, so similar titles or related items, etc. And maybe 5 recommendations or so, or maybe 10 with some scrolling. So what that could look like in our discovery layer is kind of like this. You see similar items at the bottom there. There's 5. You could put an arrow if you have more. So takeaways, overall, the algorithms perform decently for a collection, but could still be improved in a number of ways that I described earlier. If anybody else is interested in this, I mean, your mileage may vary because all collections are different, so it's very dependent on the quality and coverage of subject headings in your collection. Our steps forward, it would probably make sense to use either the most terms algorithm by itself because it performed a lot better, or a hybrid of most terms and most headings for longer and shorter subject headings if we can, check when we make the query, how many subject headings we're looking at or how long they are, and select one based on that. So this is still under active development, and we plan on exploring and implementing fixes for issues discussed earlier to improve performance, and then just reevaluate and see how it performs then and whether it's worth implementing. So that's all I got. So we have a couple more minutes if you have any questions.
Any questions for Kevin?
Is it okay if I just shout from back here?
As long as somebody repeats your question for the,
What was the question?
I don't know, she didn't ask it yet.
Oh yeah, shout the question and we'll repeat it.
Do you have any thoughts about records from other sources that have different kinds of subject information than Library of Congress subject headings?
Have we thought about how to handle items that have different kind of subject information in them besides Library of Congress subject headings?
No. No, not yet. Sure. Yeah, sure.
So presumably you want your catalog to return relevant results, and I know we're using Endeca and CSU.
Right.
Why not just use the relevance algorithm that's already tuned?
That was a.
What was the question?
Oh, sorry. Why not use the? We're using Endeca. Why not use the relevance algorithms that we've already tuned to return recommendations? So this is kind of an exploratory project for me, and I'd never used Solr before, and we were kind of exploring using that for both myself personally and as like in our core information systems team as an alternative. So that's why.
14 seconds left for a question. Okay. All right. So right now, or in a few moments, we have a break, which was supposed to start 5 minutes ago, but it goes till 2:30. What I will do is make sure you, if you have not done, oh, hey, there's a hand from Carrie.
yeah, I just want to remind people while I have a chance that if you're doing a breakout, please preload anything you want to show on the screen, if anything, on that computer. If it's on your own computer, it's probably not going to work.
You mean Lightning Talk? Okay, so yeah, so breakout sessions, make sure you put your information on the breakout board, which is by the coffee service near the reception area, or near the registration area, as soon as we break. And then I will run in here and I'll try to make a list and assign some rooms. Lightning Talks, I think there's about 6 slots left at last check. If you have not presented, if you didn't get in today and you want to do it, if it's your first time, I recommend you do it. But please, during either some slack in the breakout session time or during the break, Make sure you get your Lightning Talk material on this laptop. We will not be switching out computers during Lightning Talks because we have a very tight time limit for it. Okay, so come back here at 2:30 to see where breakout sessions are assigned. Breakout sessions go until 3:20, and then there's another break till 3:40, and back here at 3:40 for Lightning Talks. And he's going to talk about Rescarta Foundation. Cool. All right. Timer, are we ready? Yep.
Shoot me, timer. Hi, good afternoon. I'm John Cernowski with the Rescarta Foundation. This is our... How's this one? Is it in my mouth? And this is our annual update to Code4Lib. Tell you what we've been doing. Since last year, we showed you the automatic audio transcription. We were in a lightning talk where we did that, and we'll show you a little piece of that today. Since last year, we've internationalized the interface. Server administration panel's gotten some buzzes. The big thing last year we added was a single button for audio transcription. So if you're doing oral histories or you have audio files where you have talking heads, you might want to just click this little button in our data conversion tool that will automatically transcribe your data. Now, I'm wondering if this is going to work, and if it doesn't, we'll go someplace else.
You're taking a risk, man.
Excuse me?
You're taking a risk.
I know. What we're doing here is I'm just going to go, I'm on live right now, and I'm going to do a search for the word Winona in a small archive that we have up on our demo site. And of course, you're all used to seeing it in text formats and things like that. Here it is in...
Fountain City is a quaint Wisconsin river town a few miles north of Winona. Gwen Catula is a resident and owner of a business Fountain City via Winona.
You know, a great majority of my business is tourist traffic, so...
In 2008, the Winona Bridge closed for 10 days. Wisconsinites work in Winona County, with most from Trempealeau and Buffalo counties. Without the bridge, a 10-minute drive.
So basically what you're able to do with audio is the same thing you always used to do with text, but now you can merge your text and audio archives together. The toolkit, was somewhere down here. I guess it's not up there. Yeah, this is live stuff. Where the heck it went to? There it is. This is what the audio transcription editor looks like. And basically what you're looking at...
The Board of Regents okayed a plan this week that would pay for half of a $75 million renovation.
And if you find that there's something that's spelled wrong, you can redo it, you can add words, you can check it through their spell checker. So there's a nice little interface for you handling your audio materials. Again, what we did... One of these is me. What we did in internationalization, we've had Russian and Slovenian and Chinese sites for a long time. We finally internationalized the interface by taking our metadata fields. So that was English, and all you have to do is give the translation for the individual terms, and you can set it, and it sets in a little XML file by just setting the localization to your localization file. Sub-collection support, for those of you who have asking for this, it finally came. We finally bent over backward and said, okay, you can have sub-collections in the collection field. Facet filtering, everyone's been doing facet filtering forever. We've kind of fought it because we're really not a front-end game. We'd like to produce the archive and run it into ContentDM or DSpace or VUDL or Fedora, whoever else is going to do it. But our interface now does that. You can see us at www.rescarta.org. You can download the software from there. The source code's at Software Rescarta, and you can see demos at demos.rescarta.org. Thank you.
Hi, I'm Mike Giarlo. This isn't actually a lightning talk. Aren't you all in suspense now? What am I going to ask? So we have this loose convention at Code4Lib. Often happens at the beginning where we ask people, how many times they've attended before. This gives us a good idea of how many folks are new and how many folks keep coming back. I wanted to keep that tradition going. I'm doing it right now. How many of you are here for the first time at Code4Lib? Wow. Awesome. How many of you have come 2 to 3 times? Excellent. Okay. All right. 4 to 5 times. Dwindling. All right. All right. Very good. You get some claps. That's okay. Yeah, that's good. All right. 6 to 7 times. All right. Excellent. 8 times. All right. Woo. And am I correct? This is the 9th conference? Yes. Who's been here 9 times? I just really wanted to brag for being here all 9 times, so thank you.
How do we make the slides go? I'm so confused. Oh, hey, that just happened. Amazing.
Okay, hi everybody. My name is Ari Nugraha. I'm come from Indonesia, University of Indonesia. It's a very nice short trip across the globe. Okay, what is SLIMS? One thing for sure, it won't make you slimmer. Okay, it is basically as a library, integrated library system, web-based. We release it in GPL3 license. You can get it at slims.web.id. We built it using PHP, MySQL, and other open source software. I'm going to tell you a brief history. It was first initiated on 2007 to replace proprietary system. And until now, we are on 70th version. Our development motivation first to initiate knowledge sharing and to enable a library in Indonesia, especially small to medium ones, to have an affordable ILS. And also we want to free libraries from vendor lock-in. That's it. Okay. This is some of SLIM's feature. I won't tell you all of it. You can read it on our website. We have Drupal 6 and 7 integration, and also anything else you can read in SLIM's website. So why the grassroots revolution? Well, maybe I will want to talk about the ILS problem in Indonesia. First, many library have a limited fund, less attention from central and local government. The proprietary software is very expensive, and also the existing open source software are very hard to install. So we want to make a simple ILS that can be affordable to everyone. So why SLIMS make revolution? It is simple because SLIMS create freedom. For small to medium library to use, to run, to modify their ILS with minimal funds, or maybe no funds at all. This is our community across Indonesia archipelago. You know, from the Sumatra Island until the Papua Island, we already have many communities, and they're spreading SLIMS. We are very glad we have a very active community spreading SLIMS across Indonesia. So how the communities and the revolution work? First, our community doing what they call Sinau. Sinau means learning together, just sit on the floor and learning together how to use the software. They organize workshops and seminars. They also do an annual SLIMS community meetup. This year will be held in Semarang City in Central Java. If you can come in, please. So they also create a merchandise to publish SLIMS. And how SLIMS ignite the revolution? From what we think, it is the first truly free open source software for library automation in Indonesia. We use the strategy to release early, release often, listen to the communities. We want to create an easy to deploy and modify software, and we use the bottom-up approach, not from top approach. And also we always encourage our communities to take the economic value by using SLIMs. Thank you. Please join the revolution. Thank you.
Yeah, and I'm supposed to follow that. I'm actually I haven't started yet.
We need to do the thing where we make the web browser show up on the thing.
And
Why is this a problem that takes
And I
like
also
a
need to
room
be
full
able
of
to open a
advanced
file.
degrees to solve? I don't know.
Did you put the file on the computer?
Yeah.
Okay. So, where is it?
Right here. Wait a minute.
And then it should be. There you go.
Thank you.
Where are you from?
Hi. I'm from Texas. I just needed a slide to block the next slide. That's so I put something up. And also, you know, for the folks at home, hi, Michael. I'm Bobby Fox. I'm a software developer for Library Technology Services, which is part of Central IT now, but we used to work for the library, and our group is totally dedicated to supporting the library. Unlike most other institutions, although I'm told Vanderbilt is an exception, Harvard is not a centralized place. Different faculties have different pots of money, some of them very large, some of them very small. Divinity School alumni usually don't have a lot of money to give, for example. But yet, of course, supporting the library is a centralized function. But, you know, then you have to get them to part with their money. Harvard's mantra is every tub on its own bottom. Well, that's kind of hard when the library itself doesn't have a tub. Unless we get grant funded. And the Office of Scholarly Communication went out and got a whole bunch of money from the Arcadia Foundation, which generously gave us a grant for 5 years to develop the Harvard Library Lab, where librarians and others could propose projects of varying sizes, and there'd actually be funds to work on them. Lots of neat projects that the librarians actually want. Speaking of empathy. And this gave us, I'm sorry, I left a slide out, and it's not showing up, so we'll just ignore it. So we have several projects already in the pipeline. 4 years were spent doing development kinds of the activities, and then the 5th year, which is the year that we're in now, is to bring to production certain applications that were deemed worthy of going forward and paying more money. And I am one of the people who is supporting the effort to productionize it. Some of the things we have is Do We Own It, which is an app where you can get the ISBN number, like if you're in a bookstore or something, find out if the library has it. Inscriptio, which is for doing carol reservations, and that was a cute slide that didn't show up. A class request tool for faculty to make reservations to come into the library for all the incredible materials that the various Harvard libraries have. Link-O-Matic, Course Reserves Unleashed, which is my own personal project. Calvin Ma, if you're watching, I'm coming for you. And the PDS, which is Page Delivery System Mobile Web API. And some of it's even on GitHub, even as I speak. And that's me. And a hat tip to John Fink for publicizing Big, which is what I did this on, and at TMCW for writing it. Thank you. How do I get out of you know how to get out of it?
No, but that's all right. So are the presentations already loaded? No? What, how do you get to the desktop?
Listen, we're Mac shop in Stanford. Or minimize it.
On the desktop.
And then
Someone has a messy desktop here.
Close anything you don't need.
Might be faster to just close it. Don't worry, there's plenty of time. People didn't sign up.
Yes, thank you. It's going off the screen. That was easy. My name is Darren Hardy. I'm from Stanford University Libraries, and I'm going to give a little talk here about GIS. GIS is Geographic Information Systems. It's data that are spatial in nature, geospatial in nature. And we're building out the capability for building a repository that has GIS data in it that also has, that treats the GIS data as like first-class objects, making it like all the other objects that are in the repository. And part of this is that we want to be able to preserve the GIS data, we want to be able to remediate it, accession it, and so forth. And we're going to treat them as durable. That's sort of our keyword there. We'll be delivering the GIS data through the spatial data infrastructure that we've been building. And one of the important things is providing discovery interfaces to all this data. So the kind of the basic diagram here is that at the bottom you have your metadata and your data. And you wrangle up your data. Most GIS data is not like the last GIS data set that you worked on. So you wrangle the data until it submits, and then you go into the repository, and then you have a delivery mechanism so that it's akin to video maybe, where you have a delivery system where you can do streaming video. It's akin to that. And then you go into a discovery interface. So the data are typically like this. It's map data, but it's often scientific in nature. So you've got vector data, you've got historic maps that have been digitized and geo-rectified, meaning that they've been placed on the globe. So you can have a base layer that shows you where San Francisco and Las Vegas are and so forth. You can also view GIS data in Google Earth or a myriad of other types of tools, including ArcGIS, which is the proprietary tool that's totally dominant in the GIS industry. This particular data set is population data that comes from a scientific model. So the one thing I really want to talk about is the discovery interface. To date, the state of the art is sort of these geo-portals or one-stop shopping. And what we're looking at doing is making it more contextual, making the discovery process more tied to a collection, or at least a little bit more user-friendly. So one of the earlier GeoPortal applications is Open GeoPortal, and we have this deployed internally at Stanford. It has sort of a traditional GIS interface where you have multiple layers on the left. You can turn them on and off and so forth. We're building out something called Geo Blacklight right now. We're currently in the design phase, and we're looking for collaborators. It's a plugin to Blacklight that implements a GeoPortal type functionality. We also have a lightning talk a little bit later, I think maybe tomorrow, on Blacklight Maps, which is a plugin that you can use today that allows you to have a map view of your result set. And this is just another example of a collection-specific discovery interface. This is the Bossi Varati site where each manuscript, each letter is sort of tagged with a place on the map. So as far as delivery goes, you need to have a system in place that implements the services that the web mapping tools need. So we use OpenGeoSuite by Boundless, and yes, it's a complicated infrastructure. You have to build clustering, you have to build in a variety of tools that allow you to accession the metadata and assemble it and so forth. So we have these architecture diagrams of that, and for Geo Blacklight, for example, there's really just a couple key modules. We have a discovery module and an ability to download data module, and that's all integrated on top of Blacklight 5 and using leaflet web mapping. You also need a host of other things on the back end. We have persistent citation capability, we have repository management tools, we have ability to do metadata authoring, we're using the ISO standard, and we have workflows, many workflows. And this is to prove that we have a workflow, it actually works. And there's one for accessioning and assembly, there's one for the delivery, there's one for the discovery, and you also have to deal with many schemas. GIS is well known for its diversity in the metadata quality that you receive. So there's also a lot of different schemas that you have to use, and we provide translations between that all the way down to mods and to the schemas that are specific to the discovery systems. So thanks.
I know I can help you out. Hi, my name is Rosie. I have a really long title and I work with Darren. So I'm going to talk about logs, because they're your friend, but you probably haven't been talking to your friend recently. Logs, I have 3 points. Logs should be up to date. You should look at your logs when your stuff is not broken. This is key. So this is a log from an actual system workflow that Darren talked about. And you will notice that it is an error state, unable to start the accession workflow. That is actually a lie. It is able to start the accession workflow. If you go into that particular steps log, it says there's nothing in my queue. That's why it can't start the robot. Oh, so this log should be updated. Logs, logging similar things should look similar. If you have a bunch of logs that are logging similar things, make sure that they all look the same. So we remember this log here. We have another workflow that looks like this. We're not going to even talk about that unexploded array. Anyway, so that is actually logging, looking at a log of another workflow. You would imagine that they would look the same. That is incorrect. They do not. This log should be updated, or the other one should. I don't really care. One of them should be exactly like the other. Consider that you might analyze your logs one day. Maybe one day you'll have an operations manager. And they will want to look at things like CPU usage, throughput, I/O, network bandwidth, et cetera, et cetera. This is a log for checksums. So you can see an object took 2 seconds to complete, another took 10, another took 3. Awesome, checksums are happening and they're happening quickly. Does anybody know how big those objects are? No, you don't. It's a problem, right? You should know how big things are going through a process. If you don't know that, you don't know whether or not it's taking 2 seconds to complete a checksum on a terabyte file, let's say. That's probably not working. So that's all I have to say about logs. They are your friends. If you want to chat about logs, there's my contact info. You probably don't want to chat about logs, but you really should. Thanks.
My name is Michael Gibney. I'm a developer with the University of Pennsylvania Library. How do I look at that?
Where's your presentation?
Left and down. Oh, thanks. That's my name. Nice. Thanks so much. Slideshow. Nice. Thanks. Okay. So I want to give you a brief walkthrough of some recent development that we've done at University of Pennsylvania Libraries. A lot of you use Solr as an important part of the back end of your various discovery systems. And one thing that a lot of people at our library wanted from Solr that wasn't quite exactly what we wanted, or sorry, that wasn't quite exactly available through Solr was browse. And specifically heading browse in a way that was nice and took care of normalization and things like that, and faceted heading browse to leverage the faceting capabilities of Solr would be even nicer, and the ability to sort on multi-valued fields, for instance, to see a result set that is sorted by call number where a single bib record might have multiple call numbers, likely has multiple call numbers. So, just to make you all aware of the development that is going on, and let's see here. I'm going to give you a quick. So this is the discovery system. It should look fairly familiar to people. And just to start things out, I will go with an example that's close to my heart and look at sound recordings. And now let's browse by subject for rock music. You see we're presented with this list of subjects. And so it's like an interface to faceting, to an alphabetic sort of faceting, but one that handles normalization in a nice way, which the terms component of Solr doesn't natively do. So let's narrow this down. Clicking on this heading, by the way, you'll notice up here. Can you all see this? I'm sorry. Well enough? Okay. Is just like selecting that out of the facets on the left-hand side. So we've now restricted our result set, and now let's browse by author. So now it's as though we're in the record store, browsing through records in the rock music section by author. But it's restricted by subject, it's restricted by format, and you also notice that it has cross-references. So artist formerly known as Prince has use instead reference to Prince. And so that's the other component of this, is the cross-references. It leverages the LC authority file to and puts their cross-references in line into the heading browse. So just a quick example that might be more relevant to scholars would be something like to take a name that is associated with other names and see authors associated with that name. So let's take a look at William Morris. Now let's browse authors associated with William Morris, and you'll see we come up with an interesting list of associated authors, and including the cross-references and whatnot. And so that's enough of that, I guess. If anybody has questions, this is under active development, and we're looking for collaborators, people who might be interested in this functionality. I'd be interested to hear your thoughts. And the other thing, just to touch on very briefly, call number browse. So being able to sort by multi-valued, we're filtering still. being able to sort by multi-valued fields. This is just a quick example of the results that you get when you do that. And it allows you to do custom call number schemes. So you'll see, and also to do things like numeric sort as opposed to lexicographic sorting, and that's all.
Hey, we're like early for the first time ever. I don't know, maybe not the first time ever. But yeah, so I guess we are mostly pretty much done for today in terms of actual content. I can stand up here for a few minutes and talk at you because you all really want that. But the next thing on the actual schedule, well, daily wrap-up doesn't start until half an hour from now, so I'm just going to stand up here and no. So we're wrapping up early, but the next thing after wrapping up that's on the schedule is at 5, the buses for the Hunt Library Tour and Noshing and Beer will be showing up. If you go down 2 flights to the back entrance across the street from the parking lot where there's that semicircle, I think that's where the buses are coming, right? And they will start picking up at 5. There's 3 buses. I think they're just going to keep circulating more or less. Do we know what the plan is when people get to Hunt? Does anyone know that? I think you go in, bring your badge. We want to make sure that only people at the conference are getting the booze and the pizza and not students. And the way that we are going to discriminate between students and not students is by your badge. Okay, so the buses going there will be going for 45 minutes, and then when do they start sending people back? 6:45 for 45 minutes, they will be sending people back to the hotel. And once again, the buses start at 5. Is there anything else we need to? Oh, hey, presenters for tomorrow. If you want to come up and put your presentations on the laptop now, that would be a really swell idea. And also lightning talks for tomorrow. You could do the same thing if you've magically created your lightning talk for tomorrow already. There's also, I think, maybe 4 slots left for tomorrow's lightning talks. The easel's still out there. Feel free to do those. They're very low pressure, as I hope you just saw. I encourage you to do them. Pictures at Hunt? What about pictures at Hunt? Yeah, all right. Tim apparently has more informed things to say than I do.
So those of you who are going to Hunt are probably going to want to take pictures, and that's great. Hey. So just so you know, please be mindful, it is an open library, there are students around, and they have become sensitive to getting their pictures taken without permission. So just kind of get that out. You will get out to Instagram if someone catches you taking their picture without. It's apparently been known. So, and you'll probably get on the big visualization board saying, "Hey, this is my Hunt library. Stop taking my picture. I'm here studying." So just be mindful of that because there have been a lot of visitors over time frames. So take pictures, but just be careful not to get people who are there just kind of there to study. So, otherwise, I think we're good for today. Cool. So, and
anyone have questions or other things that have come up? Oh. Hey, breakout sessions. Someone from the each breakout session, we have made a wiki page for you to include any interesting findings or comments about your breakout session. We encourage you to post them there. Are there any questions? Internet, yeah. Questions, others, comments? How do you get an account on the wiki? I think you have to email Ryan Wick, who's apparently waving his hand. So that's who Ryan Wick is. Okay, cool. Anything else? Company dismissed.